Good morning, everyone. Today is Wednesday, November 15. So today you have homework 8 and quiz 5. Okay, everybody? So don't forget to do the quiz. And yeah, today we will continue on session 6.5. Okay, and then Friday we will talk about 6.6. All right, let's see. So last time we talked about example 1, right? And the first step is you draw the pictures, name the variable, what is constant, leave it the number. If it's a constant, it does not change. And just put the number there. But if that quantity is changing, then we name the variable. So in this case, we have the horizontal distance, that's the x. And the vertical distance, that's the y. And then the z is the distance between them. When the two airplanes they're going to the airport, the distance are all decreasing, right? So that's why the rate of change is like the speed. If the distance is decreasing, you know the rate of change is going to be negative, right, everybody? So we translate all the information to math symbols, and we find the relation between x and y and z. We get the Pythagorean theorem, and then we differentiate. This is where we introduce the rate. The rate is the derivative with respect to time. Okay, everybody? It's like doing chain rule. Every time you differentiate a variable, you multiply by u prime at the end. U prime in this case is like d of that variable dt. Do you still remember? After we differentiate, then we can plug in the numbers and solve for the rate that we were looking for was dz dt. So we solve for dz dt. So this is the process. And let's do more examples today. So example 2, we have sand falls from an overhead bin accumulating in a conical pile with a radius that is always 3 times its height. So let's draw some picture. We have overhead bin and accumulate and form a cone. And then this cone, it has the radius is always 3 times its height. So radius is 3 times its height. Right, everybody? So what is changing? Well, if you have more sand, your radius is changing, is increasing, right? And your height is also changing. Your height is also increasing. So that's why we set both of them as the variable. We have height, h, and radius, r. If the sand falls from the bin at a rate of 120 cubic feet per minute, do you see here? This is sometimes from the unit you can see what quantity it is. If it's only feet, then you know this is a length, right? If it's square feet, then you know this is a area, right? Cubic feet is a volume, right? The cubic feet per minute, this is dVdt. And your volume is increasing. Yes, everybody? You have more sand, so your volume is increasing. Therefore, dVdt is 120. Any questions so far? All good? Your volume is increasing because more sand falling down, right? And it tells you that it has a rate 120 cubic feet per minute. So this is dVdt. And then the goal is how fast is the height of the sand pile changing? So we want to find how fast is the height changing. So we're looking for dH dt, right? Our goal is to find dH dt when at the moment when the pile is 10 feet high. So when h equals 10. By the way, h is changing. It just asks you to find the rate of change of the height at the moment when the height is 10 feet. Okay, everybody? Alright. So here we have V and we have R and we have H. We want to find the relations. What is the volume of the cone?
Third,
Exactly. So V equals 1/3 pi R square H. Right. So this is the volume. And oh, do you see we have the relation between H and R? Okay. But we're looking for dHdt. So it's better to get rid of the R. Yeah? So let's get rid of the R. So substitute. R equals 3h. Okay. So substitute. We get V is 1/3 pi. R is 3h. But it's R squared. And then times h. Okay. So we plug in. Oh, can we simplify this? What is 3 squared? 3 squared is blank?
3 squared is
9. And then we have h squared. And there's another h. Oh, what happened? Yeah, exactly. And the 9 and 3 cancel. We get 3 pi h cubed. Okay. All right, attendance. Okay. So we continue. All right. So this is the relationship between B and H. Well, we're ready to differentiate. Okay. So take the derivative of both sides with respect to t. And then on the left-hand side, we get dv dt. And on the right-hand side, 3 pi stay here. What is the derivative of h cubed? 3h squared. But when you differentiate the h, multiply by dh dt. Right, everybody? So 3 pi and times the derivative of h cubed is 3h squared dh dt. All right. And now we're ready to plug in the numbers because dv dt is 120. And oh, you see, we have 3 pi and 3. What is h? 10. And then we have dh dt. That is what we are looking for. We're looking for dh dt. So let's both sides divided by this. Because it's a multiplication. So both sides divided by that. we get the h dt is 120 over 3 pi and 3, and 10 squared is like 10 and 10. Let's try to simplify. Do you see the 10 and one of the 0 cancel? And the 12 can cancel with the 3, you have 4 left, right? 4 and 10, you can cancel the 2, then you get 2 and 5. So our answer is 2 over 3 times 5 is 15 pi. So this is the answer. And what's the unit? What's the units for the height? Feet per minute. Very good. Yes, feet per minute. And you can see this number is positive because our height is increasing. So this answer makes sense. Okay, if the problem also wants you to find the rate of change of the radius, then you can take the derivative here. You get dr dt is 3 times dh dt, right? So yeah, we already finished this problem. I just want to tell you more. If the problem asks you to find the rate of change of the r, so you can look at this relations. When you differentiate, the r dt is 3 times the h dt. Therefore, the h dt is 2 over 15 pi. Can you cancel the 3 and the 15? And get 5. So we get 2 over 5 pi. So this is the rate of change of the radius. And it's also positive because your radius is also increasing. All right. Any questions about this problem? Yes.
My question is why you always multiply by
du ht, that's the chain rule. Okay. Do you remember when we did the implicit differentiation? When it's like, okay, x squared plus y squared equals 10, something like that. 10x, like this. When you take the derivative with respect to x, well, then what are you doing? Here, you get the 2x. Well, you can think of chain rule is 2x, and then you multiply by dx dx. But dx dx cancel, you only get 1. But when you differentiate the y, you get 2y times dy dx. And this is the chain rule. Okay? This is when we do the implicit differentiation. When we differentiate the x, it's just the regular formula. You don't need to multiply by x prime because x prime is 1. But like here, what's the derivative of 10x? 10. And if you put the x dx, that is 1. So it's only 10. But in this case, you are differentiate with respect to t. Therefore, all the variables, see t, the r and h and the v, all the variables, they are not t. They are not t. So when you differentiate, you need chain rule. Chain rule is you multiply by that variable prime at the end. So when you differentiate v, well, the derivative of v is 1 times dv dt because of the chain rule. Right? And what's the derivative of h cubed? 3h squared, right? And you multiply by the h prime. So all the variable when you differentiate with respect to t, you multiply by d of that variable dt because of the chain rule. So yeah, if you it's like you have dv dv. If you differentiate with respect to v, you get 1, right? But here is dv dt. That's why dv squared, dv is 2v, right? And then dv squared dt is 2v, but then you need to times dv dt. Because you take the derivative with respect to t instead of v, you need to use chain rule. As long as that variable and this variable, they are not the same, you need chain rule. Okay? Right? So, thank you about this. Because if you don't put the HTT, how can you find the HTT? If you don't put it here, where can you find the HTT? It's because we have the DHTT, so we can solve for it. If you forget to include this, then your equation has no DHTT, and how can we find it? Right? Similarly here, implicit differentiation. If you forgot to put the y prime, how can you find the slope? You don't have an equation with the y prime. How can you find the y prime? That's why the chain rule, the y prime, the rate, is very important. Because if you forget that, then the equation does not have that thing. We cannot solve for it. So make sure you have the chain rule. Okay, any questions? All good? Let's keep going. Okay, so a light is on the top of a 12 feet tall pole. Okay, and so the lamp is right here. And then the pole is 12 feet. And a 5 feet 6 inch tall person. So how many inch in a feet? In a foot? Huh? 60? To 12. 12. So 1 foot equals 12 inches. So 6 inch is like 0.5 feet. So this is like 5.5 feet. All right, everybody? So we have the person right here, 5.5 feet, and it's walking away from the pole. So walking away, so going this way, at a rate of 2 feet per second. Okay, so 2 feet per second is the rate of change of the person walking. Okay, and look at this picture. Let xp be the distance between the person and the pole. Okay, and let xs be the distance between the person and the tip of the shadow. And let x be the distance from the pole to the tip of the shadow. Okay, so then, well, the speed of the person walking is actually the rate of change of the xp, right? Because your pole is not changing, it's stay there. And your person is walking, so your xp is changing, and then the rate of change is 2 feet per second. So part A, at what rate is the tip of the shadow moving from the pole? See, the tip of the shadow moving from the pole. You're talking about the x, right, everybody? The distance from the tip of the shadow to the pole is x. We are looking for the rate of x. So part A, we are looking for dx dt when the person is 25 feet from the pole, when the xp is 25. Right, everybody? Okay, let's see. Okay, so do you see here we have two similar triangles? So let's give it some letters. So OAB, and let's say this is CD. Can you see the triangle OAB is similar to the triangle OCD? Yes? So similar triangles, then the ratio of the corresponding sides are the same, right, everybody? So here, which side do we consider? We know the information of AB and CD. We should use these sides, right? And we were looking for, this is XS and this is XP. So do we want to compare the AB and BD? No, this is O. AB and BO and CD and ZO. Right, everybody? So do we use the hypotenuse side? Do we use hypotenuse side here? No. We don't really asking for the distance here. Okay? We know the opposite side, and we know we want to find the adjacent side. Okay? So only use those two sides. Alright, so therefore we get AB over OB, the corresponding side with the same ratio. And then here, AB corresponds to CD. Yes. How about OB? It corresponds to what, Dylan? OD. Everybody okay with similar triangles? Okay, now let's plug in the numbers. Thank you. What is AB? Paige, what is AB? Look at the picture. What is AB? AB is 5.5. All right. OB. OB is XS. Right, anybody? OB is XS. But the problem is we know XP prime and we're looking for X prime. So we want to find the relation. So we want to find the relation between XP and X. Do you agree? Because we know the XPDT and we want to find the XDT. So that's why we want to find the relation between XP and X. We know OB is XS. But you can write XS in terms of XP and X. So what is XS in terms of XP and X? This is, do you see this 2 sum equals that? Yeah. So XS is, exactly, X minus XP. So OB is X minus XP. Very good. And then CD. What is CD? $12. Right? How about OD? X. Yes. Okay. And then, let's simplify it. Did you learn like cross multiply? If both sides is a single fraction, you can cross multiply. But this is only true when you have single fraction on both sides. If you have more than one fraction on one side, can you do cross multiply? No. Right. Okay, so cross multiply. You get 5.5x equals 12 times parentheses x minus xp. The parentheses is very important. Okay, don't forget the parentheses. Let's distribute. So 5.5x is 12x minus 12xp. How can you simplify? So subtract that, right? Subtract 12x on both sides. And what do you get? Negative. Yes, equals negative 12xp. Can we both sides multiply by minus 1? Yeah, because both sides multiply by minus 1. We get that. Great. This is the relations between xp and x. Once we find the relations, we can then differentiate. Okay, we can then differentiate. Look at the left-hand side. When you take the derivative, what do you get? 6.5. The derivative of 6.5x is 6.5 times x prime, which is dx dt, right? And then the derivative of 12xp is what? 12 times dxp dt. Everybody okay? You get used to the differentiation. You take the derivative. It's the regular formula multiplied by d of that variable dt. Yes. Okay. What do we know? Dx dt is 2, right? We plug in dx dt is 2. So dx dt is what? 12 times 2 and then divided by 6.5. Okay, what is this number? Oops. Do you have calculator? What is 12 times 2 over 6.5? 3.69. How about 3 decimal places? 2. Okay, thank you. And what's the unit? Feet per second. Yes, so this is part A. We get the xdt is 3.692 feet per second. All right, so this is part A. Part B. At what rate is the tip of the shadow moving from the person? See, the distance from the tip of the shadow to the person is xs. So part B, we're looking for the xs, right? So part B, we want to find the xs dt. Wow, look at this part. See, this is the relation between xs, x, and xp. Now we know the xdt and we know the xpdt. So we can differentiate this side. Okay, so we differentiate, we get, oops, dxs dt is what? When you differentiate, what do you get? Yes, dx dt minus dxp dt. So we have, what? Is it 3.692 minus dxp dt is 2, right? So we get 1.692. Also feet per second. Mhm. All right. Okay. And then this is the solution of example 3. Any questions about example 3? So the story problem is hard because different story, it involves different picture. Then if it's a triangle, you might use Pythagorean theorems. If you're talking about the size and the angle, you might use the trig functions, right? And here there are 2 triangles involved, so we use similar triangles properties. So the story problems, you don't know what story it is. You don't know what geometry figures you're gonna use. So that's why application problems are hard. So practice more. Okay. Example 4. A piston is seated at the top of a cylindrical chamber with radius 5 centimeters. When it starts moving into the chamber at a constant speed of 3 centimeters per second, what is the rate of change of the volume of the cylinder when the piston is 2 centimeters from the base of the chamber? Okay, so this is the chamber. We have this thing is the piston is moving down. Can you imagine the picture? It's moving down. Okay, let me ask you. In this process, when we move down, will the radius change? No. Right? It is the same cylinder. It's the same cylinder. So the radius does not change. Do you want to set a variable for the radius? It does not change. No. So this is a good example. When we set up the variable, always ask, is this changing? Okay? If it's not changing, give it the number. So in this case, my radius is always what? 5 centimeters. Okay, this is fixed. And is my height changing? When you push down, is my height changing? Yeah. If you push down, your height is smaller, 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 right? And your volume is smaller, smaller, smaller. So H is changing. And also V is changing. Okay. So, and it moves into the chamber at a constant speed of 3 centimeters per second. Questions. Your height is increasing or decreasing? Decreasing. So your rate of change of the height is positive or negative? Negative. And it's -3. Yes, everybody? You're moving down with the constant speed, 3 centimeters per second. And because you're moving down, your height is decreasing. We want to find the rate of change of the volume. So we want to find dV dt when the height is 2 centimeters from the base of the chamber. So we set the variables and we figure out what we're looking for. So in the exam, don't give up. Draw a picture, set the variables, write down the relations. You get points. Okay, so don't leave the problem blank. So write down as many steps as you can. All right. What is volume of a cylinder? What's volume of cylinder? Pi r squared h. But your r is what? 5. Oh, you see, everybody? My r is 5. Okay, good. So we have V is What's 5 squared? 25 pi times h. Yes, everybody? So this is the relation between b and h. We're ready to differentiate. What's the derivative of v? What's that? Yeah, dv dt. What's the derivative of the right hand side? Pi and then d h dt. Yes. Okay, now we can plug in because the HGT is -3. So 25 pi times -3. What is this? 3 times 25 is 75 pi. Yes? So put this in your calculator. What do you get? Give me 3 decimal places. Thank you. And the unit, what's the unit for the rates of volume? Yes, per second. Yes. So that's the unit. Okay, everybody? All right. So this is example 4. Okay. And I want to practice more with you. Do you remember the first problem where you have the airplane approaching the airport? The distance x and y and z are all changing. I want you to look at a different example. Like we have a house here, okay, and I have a letter. Okay, the letter is 5 feet long. And then I pull the letter to the right. And can you imagine what happened? And the letter will drop down, right? And if I pull the letter from the right, okay, let's say we set the variable. And let's say I pull the letter to the right 2 feet per second. And then I want to ask you what is the rate of change of the letter drop down. Everybody understand the problem? So when you set the variable, okay, how do you set the variable? You want to ask, is that quantity changing? Here, is that quantity changing? Yes. So because it's a horizontal distance, you set it up as x. And then here, is this quantity changing? The vertical distance. Is it changing? Yes. So we set it to be y. And then the length of the ladder, is it changing? No. See? This is 5, and it's always 5. And also think about more. When I move the letter to the right, your x is increasing or decreasing? Increasing. So my dx dt is positive or negative? Positive. So you set it up as 2 instead of -2. Furthermore, your y is increasing or decreasing? Decreasing. So we know that dy dt is gonna be negative. Yes? So here it's also Pythagorean theorems. You get what? What's the relation between x and y? Pythagorean theorem, what do you get? Yes. Right, everybody? So we can now differentiate. What is the derivative of y squared? 2y times, yeah, y prime. Okay, so if you get used to it, the y prime or x prime, yeah, that's easier to write because you just put a prime there. And what's the derivative of x squared? Yeah, what's the derivative of 5 squared? The derivative of a constant is 0. Yes. Oh, can you see we have a common factor too? Both sides divided by 2. So we get y times y prime plus divided by 2, x times x prime. Okay, I should say find the dy dt when x equals 3 feet, like that. Okay, so now you can plug in the number. Oop, what happened? Oh, okay. Where is it? Oh, okay, so right here. Okay, so we plug in the number. X is 3, yes? X prime is what? 2. Y prime is what we are looking for. But the y, okay, look at the y. At the moment when x is 3, yeah, y must be 4. Right, everybody? You know the triangles 3, 4, 5, 5, 12, 13? Yeah? Mm-hmm. Okay, and therefore this must be 4. And we set this equal to 0. So 4y prime is -6, right? And y prime is -6 over 4, so -3 over 2 feet per second. So this is the rate of change of the y. So I just want to show you this example. So you know, when you set the variable, ask, is it changing? If it's changing, set the variable. If it's not changing, put that number there. The 5 is constant. Put that number there. Don't call it z. Okay? Because if you call it z when you differentiate, what happens? It's 2z dz dt. And this is 5. It's not changing. You can also do that, but your dz dt will be 0 because your z is not changing. Right, everybody? All right. So this is the related rates session. Any questions about related rates? So do more exercise. Okay. And these are the formula of the 2-dimensional figures and 3-dimensional figures. All right. Let's see. Okay. All right. So next one, 6.6. Linear approximation and differential. Okay. So we talked about how to find tangent line at a place. Do you still remember how to find the tangent line? We need the derivative. That's the slope, right? And we also have a point. Let's say this point is a f of a, right? And the derivative is f prime of a, right? So with the f prime of a is the slope, and with the points, we can use point slope form to find the tangent line, right? So we have the point a, f of a, and then our slope is f prime of a. Therefore, the point slope form, we have y minus f of a equals to the slope times x minus a. And then when you solve for y, you add both sides by f of a. Therefore, your tangent line is f of a plus f prime of a times x minus a. This is the tangent line. Yes, everybody? So, this class, linear approximation, is talking about we want to use the tangent line to approximate the function value. So when x, let's say this is a, and let's say this is x. When x is close to a, do you see this is our tangent line and this is the function? They are so close, right? And if my x getting closer to a, oh, do you see here? They're almost the same, right, everybody? So, yeah, this class is about how do we use the tangent line to approximate the function value when the x is near the point A. Right? So, yeah, print out 6.6 worksheet and let's continue the next class. By the way, do you receive my email about the extra credits? Tomorrow, yes, we have international meet and greet events in the Andover Commons second floor. The science conference rooms is right above the kitchen. And it starts from 5, so 5 p.m. to 6:30. And there'll be food and a lot of practice.
So to get the extra credit, do you have to be there?
You have to be there and take a selfie with me in the background. Then email me the picture. Okay.
Smaller than that.
He can still come. Yes. So,
Alright.
Oh.
So it was like a couple $100 cheaper to go on Sunday than it was every Saturday.
Let me see. What do we do on Monday? Oh, Monday. We talked about 7.1. You can draw online, but according to the rule, if you draw online, it's still considered as absence. But I give you an opportunity. So if you miss no more than 2 classes, then you still get the 1% attendance bonus. If you miss no more than 6 classes, it's still okay.
Yeah, I think that will be my third miss.
Oh, okay.
But I'm not 100% sure.
Let's see. So, right.
4.
1, 2, 3. So the fourth one.
Okay, so
Yeah.
I'm still good.
Yeah.
Alright,
Okay.
I just want to make sure about that because it just did not make really financial sense for me to go.
Totally understand. But don't forget to do the quiz.
Yeah.
So join online and do the quiz.
Oh, so please go up a little bit.
Go up a little bit?
Yeah.
Like this?
Yeah, that's fine. So quiz 5 tonight, right?
Yes, tonight.
It's basically the homework.
Yeah, the homework 8.
So what we did today, so homework 8 is 6.4.
I think so. And then homework 9 is 6.5 to 26. Did you do your homework yet? Okay. Yeah. So your quiz is about that. Okay.
All right,
You're welcome. Have a good day.